Here we're looking at the derivative application called elasticity of demand. This is applying derivatives and seeing their use in economics. The actual explanation of elasticity of demand is really more in the scope of a different economics course. I will just give you a brief overview, but I'm not going to go too much into interpreting anything. We're just going to see how derivatives can be used in this business economics application. So if a demand is elastic, that means that there is a big change in demand when you have a change in price. So you change the price and the demand is going to change pretty drastically, versus inelastic means you can change the price and the quantity demanded is going to be pretty small. So there's not going to be a huge change in demand even when you change the price. Kind of makes me think of an iPhone. If the price of an iPhone went up significantly, I don't think it would impact the demand too much, because it's like once you're an iPhone user, it's hard to go back to Droid. So elastic means big change in demand if you change the price. Inelastic means small change in demand if you change the price. And then unitary means it's proportional. So if you change the price by a certain amount, the demand changes by a pretty similar certain amount as well. So we're going to get into how to use the derivatives to look at this and not really talk about the interpretation, but just to give you an idea of what it means. Big change in demand for elastic if you change the price. Small change in demand for inelastic when you change the price. Unitary means proportional change in demand when you change the price. So looking at this demand equation, we have f of p is negative 3/2 p plus 15. So you don't even really have to understand a demand equation. We're just going to apply it to some calculus by plugging into this formula here. So the elasticity is going to be found by doing negative p, and this is something I would circle, negative p times f prime of p all over the original f of p. Not a formula that you have to memorize. You'd be given it in a course, or you could look it up online. If you were trying to use it real life at a job or something like that, you would double check before you make any recommendation. So not something I would suggest memorizing. So E of P is going to be negative P times the derivative f prime of P. So we need to take the derivative of this function we're given up here. So derivative of f of P, we're going to do derivative of negative 3/2 P. That's our mini rule. Derivative of 5x is 5. Derivative of 2x is 2. So derivative of negative 3/2 P is just going to be negative 3/2. And then the derivative of 15 is 0. So we plugged into the first two pieces. We did negative P, we did the derivative, f prime of P. All over the last piece is the original function, which was negative 3/2 P plus 15. I'm going to multiply the numerators together first. The numerator is going to be positive each time that we multiply it out. So if negative P times negative 3/2 is just going to be positive 3/2 P. So we have a positive numerator and negative 3/2 P plus 15 in the denominator. And it says to simplify any complex fractions. So I know I have a complex fraction because my numerator has a denominator. So I shouldn't have a fraction within a fraction. So I'm going to simplify that. So to get rid of that denominator 2, I'm going to multiply every single term by 2. That way we don't have any fractions within a fraction. So in the top, 2 times 3/2, those 2's just cancel out and you're going to be left with 3p. In the bottom, 2's will cancel out and we'll be left with negative 3p. And then super important, it's not plus 15 anymore. 15 also has to be multiplied with 2 as well, just to not change the value of the fraction. It didn't have a complex fraction, but we still multiply every single term by 2. So we're going to do negative 3p plus 30. So there's my E of P. That's how we would find the elasticity of demand for any price P that we wanted to set our goods at. The next part says, is the demand elastic, unitary, or inelastic when the price is $8? So I'm going to figure out what is the elasticity when the price is $8, which means I'm going to replace each P with an 8 in parentheses. So I'm going to do 3 times 8 in the top. And I might just multiply it piece by piece. I think it's easier than plugging the whole thing into your calculator. So 3 times 8 in the top is 24. In the bottom, I'm still plugging into this part A here. So we have negative 3 times 8 plus 30. So negative 3 times 8 is negative 24 plus 30 gives me 6. So 24 divided by 6 is 4. And it says, is the demand elastic, unitary, or inelastic? So nothing to memorize here. I just need to look back up at this box. It's elastic if it's bigger than 1, unitary if it's equal to 1, or inelastic if it's less than 1. So which case do we have here? Is 4 bigger than, equal to, or less than 1? We would say 4 is bigger than 1, and then give our conclusion. Bigger than 1 is elastic. So our answer is 4, which is bigger than 1, which means the demand is elastic. You don't have to interpret what that means or make any suggestions based on that. If you understand what it means, that's great. If not, hopefully you have the chance to take an economics course and figure out exactly where to go from there. The last part says, for what P is the demand unitary? Looking at this interpretation box, bigger than 1 is elastic. Unitary means equal to 1. So I want to make E of P equal to 1 and see what price we'd have to set our commodity at in order for that demand to be unitary. So I'm going to take E of P from the first part, right? We found that in part A up here. And I'm going to set that equal to 1. So I have 3P over negative 3P plus 30. We're going to set that equal to 1 and solve for P. So the first step to solving this is that we need to solve for P, and we need to get out of the denominator in order to do that. So I'm going to multiply both sides by the denominator. Negative 3P plus 30. Negative 3P plus 30. That way we can cancel it out. If you want to solve for a variable, get it out of the denominator first. So on the left, you just have 3P, and on the right, you have 1 times negative 3P plus 30. Well, 1 times anything is just going to stay itself. So what we end up with here is the numerator equals the denominator. Okay, there's kind of a pattern when you're solving these. And I want to solve for P, so I'm going to put the P's all on one side and the numbers on the other. So I'm going to add 3P over. I want to get them on one side by themselves. So I have 6P equals 30. And I'm going to get P by itself so I know what price to set it at. So lastly, I'm going to divide by 6. So the price is going to be 30 divided by 6. The price is going to be $5. If it didn't come out to be a nice whole number, I would note around to 2 decimal places because we're talking about setting price. So our price is $5 in order for it to be unitary. The nice part is I can grab my calculator quick and make sure that this works. I can check my work on this before I send out any sort of recommendation and make sure E of 5 really does equal 1. It has to equal 1 to be unitary. So I'm plugging in to that first part again. I'm going to do 3 times 5 in the top. So in the top I get 15. And then the bottom part is negative 3P plus 30. So negative 3 times 5 plus 30. Just doing a quick check off to the side. Negative 15 plus 30 is going to be 15. I get 15 over 15, which is 1. All right, if we really set the price at $5, we're really going to get that the demand will be unitary. So there's elasticity of demand. We use the derivative, not a bad derivative to take. There wasn't a product, quotient, or chain or anything. So we do negative P times our derivative all over the original function, and then we can use it to plug in to see what types of demand we have for certain price points, or if we want to get to that specific unitary price point where the demand is proportional to our price increases or decreases, we can figure out what would make the demand unitary by setting E of P equal to 1.